Alrighty. Hey, we are live. Hello, everyone. What's up? Hello. What's up, everyone? And welcome to another LearnDay. Yeah. All right, cool. I was trying to fix something before we started, but I don't know why it's not working. All right, so let's see who's here already. And once people get here, we can start with today's topic, which is gonna be VEX. Cool. All right. Oh, there's a few of you here already. MES, what's up? Felipe, Santi, what's up? Felipe, what's up? Santi, Bob, what's up, Bob? And Orlando. Hey, Orlando. Yeah, we're gonna do some VEX today, because Matt Estela did this amazing guide. He's been working on it for a while, but he said it's ready and it's been tested and stuff, which is cool. So I said, well, let's give it a try, and that's what we're gonna do today. Let me just check something really quickly. So how you guys been? Not launching. I don't know why. Launching. Steven Shug. What's up, Steven? John Su. Hey, what's up, John Su? Maitland Bogan Turner. That's a cool name. Yeah, it's better if you just watch me type today, and then we can you can try it later, maybe. All right, I'm just gonna have to live with this thing for today. What else? I'll debug it later. Alrighty, so who else is here? Bob, yeah, doing great as well, Bob. Thank you. I'm fine. Ever. What's up, Ever? Grimmy from Toronto. Hey, what's up? How's the weather there, man? Should be getting nice by this time of the year in Toronto. Moneyball. Hey, the Caribbean. Oh, that should be really cool weather. Cool weather. MA. What's up? It's too cold? Oh, man. Come on. I am not going to GDC. If you're asking me, I am not gonna be at GDC. Sorry. Sunsho. Are you Nacho? What's up, Nacho? Argentina. Cool, man. Cool. Ever is from Brazil. Cool, man. No, I'm not going to GDC. I don't have anything to do at GDC actually. Sorry. Felipe is in London. Awesome. Sermon, you're already at day 9? I'm not sure how far am I gonna get here. All right, so let's get started here. So let's see where I got the thingy. Let me get the right window first. Alrighty, let me switch my camera. Right, there we go. Oh, I'm in the middle of the picture now. I guess I need to be there. What should I put my image? I don't know. All right, so just a reminder, if you don't know, we have courses for sale, or they are there. They're not on sale, just different longer term courses that you can take on our site if you don't know, mixtrn.com. And it's all good. It's cool. Thank you everyone that has bought our courses. It's very helpful for us. All right, so we're gonna start with the Joy of VEX, and this is a guide that I did not do first of all. So let me start this again, and I am gonna start learning this as we go. I haven't seen this guide. I've seen it. I read a little bit of it on day one, but I haven't done it. Like, I haven't gone through everything. So basically this is gonna be like me going through it, trying to explain whatever's happening, if I can explain it. And that's basically what's gonna be this thing. Since this is done by Matt Estela, which is amazing. The whole wiki here, it's amazing. I'm gonna put the link to this. Let me open code. So if you don't know, I should open a folder. Let me create a folder really quickly. In training, I'm gonna create a folder here for VEX. Joy of VEX, and this is gonna be our folder for the code. But I just want to show you the let's say the one that'd be what's the BFL? Yeah, I think that's yeah. So this is the, let me show everyone this before we start. This is the address for the, and this is made by the awesome Matt Estela. He works at Animal Logic in Australia. I think he's still there. He was going to switch. I'm not sure. I'm gonna talk. So that's the the link. If you go to the CG Wiki on this address, there's a lot of articles there, or small scenes and stuff about VEX, about Houdini. It's amazing. You should go there and check it out. Actually, we need big font today, right? Let me change the settings of the font really quickly. Let's go for 34. Whoa, that's huge. That's good. We'll keep that open in case we need it back. All right, so day one. So again, basically this is gonna be me learning this thing as well. So I haven't done any of this, and this is Matt called this the illustrated the Joy of VEX, an impatient guide for wrangles. And I'm more impatient than this, so I'm gonna go through maybe 3 days at the time. I don't know, but I'm gonna keep doing this at every stream. I'm not gonna skip ahead or anything. So let's see how much we can cover today, and then we can next week we do something else, and until we finish this thing. All right, so let's just see if there's an question. I don't know about Animal Logic and works. I'm working there, so check their site. VEX is kind of hard. VEX is alright. It's not that hard actually. And Grant, it's on the chat, and he helped debug or test the code here. So if you have questions, Grant can help us in the chat. So all right, that's enough talk. Let's go to day one. So day one, there's a file here that you can download. Should I download that? Let's download the file. I don't generally like to open this files that are non-commercial because they might screw up my Houdini. But I'm gonna open another one. So let's see that file. Let me just want to see what's on that file. It should be a simple file, as I read there. Here. Accept that. And yeah, open it. Destroy my life. No. Alright, so it's just a grid with some stuff here, and then there's like a point wrangle here already for us to type. Sorry, one time, last time, no. Crap. All right, so what I'm gonna do is I'm gonna do the code here in Visual Studio Code, so you can guys all see that because it's gonna be bigger font. Maybe even make it even larger still, since we're not gonna type that much, but I want you guys to see the font. I'm gonna do it here, and then I'm gonna paste it in Houdini to test it. All right, let's make this size of the screen. All right, so if I type here, this is gonna be too small, so I don't want to do that. So I'm gonna do it here. So we have a grid here. Let me show the thingy. This is the scene that Matt provided there. Let's go back, and it says that I'm not gonna read everything. There's a configure thing because we're gonna just be here all day. Being able to see your geometry attributes. So if you want to follow along, just open the page and you can read with me. Geometry attributes is important when using VEX. Alright, so he suggests that you have this guy over here all the time, like the attributes, which I actually have all the time open. So I'm good. And now we're gonna do color. So basically, it's simple. It's passing the. Let's make this bigger as well. It's passing the normal to the color. So basically, if you don't know anything about VEX, this ampersand, no, this is not the ampersand, the @ symbol here that you use for emails and stuff. Just think about it as attribute. When you see this, think attribute. That's it. We decoded that already. So let's put it here. I want to have this open all the time actually. Let me reconfigure my viewport. Yeah, so we can have this open all the time, and then Houdini here. That would be better. Keep above others. All right, so this is saying that we should, and the CD attribute, if you should be familiar with that, which is basically the color attribute, which is an attribute for color. When you add it to color, so to something, there's an attribute created, and the name of that attribute is CD. So basically, we're saying dollar, or not dollar. At CD means, so now I can make this guy top here. I'm not gonna do this. So basically it's at CD means attribute color. It's gonna be equal to the attribute normal. So if we go here in Houdini, we can see that we have a normal attribute that is being created by this guy, which should be here in the spreadsheet. Here is the attribute called N, which is the normal. If we middle click here on this guy, we should also see the N attribute there. I didn't make Houdini larger. I should do that. general user interface and set HTTP apply accept. Let me reopen this just really quickly. Discord. So basically that's it. It's basically we are saying grab the attribute called CD. That's what that means. And then we're saying here grab the attribute name normal and put it to the color. So basically we're converting the normals to a color attribute, and then we're gonna get this fancy thingy here. So let's open that guy again. And nope, I need the space. So let's put this into Houdini now. Here, let's put it there, and control space, control enter, sorry. Let's switch to something better like a sphere. So now you can see the normals. The normals are just basically directions pointing in different directions, and that's what we are having here as colors. If you think about, you can see the green is up like this guy. Going up is it's the green color. Going in the x-axis is the red color, and going in the z-axis is the blue color. So that's why we see this mixing here. But basically, up is the y-axis. Then this is the x-axis, and this is the z-axis, and that's basically what we're saying here. Just make those normals, pass it to color. So let's see what then is. Then the position it's passed to the color. So just put P there, which is P means the position, and it's basically the same thing, but it's a lot brighter because positions have bigger values. You can see here some positions go up to 3, and the color here is being multiplied by that. So that's why it's brighter. If we make the sphere larger, this color should get brighter actually. Yep. If we made it smaller, you can see the values are getting smaller, because basically it's getting the position, the value of maybe this point, the position of that value, and passing it to color. So that's what's happening there. So let's see, rotate, translate, scale via the transform sub to see the values change. Oh yeah, let's change to the pig. And let's switch to the no lighting version, hide the points, and let's play with this guy. And yeah, you can see the values are changing because we are moving the points and they are calculating the positions, passing them to the color, right? That's simpler to understand. Attribute components. CD is a vector, and if you don't know what a vector is, that sounds like, what the hell is a vector, dude? So basically a vector is just does he explain it here? So basically it's this right here. A vector is just a value that has it's composed of 3 values. So this is a vector, 1, 1, 1. That's a vector. This is a 3. Yeah, this is a vector, and that's what it means basically. It's just 3 values for one thing. That's basically what it means in a vector. Let's see. And vectors, if you want to go more into math, they have direction, length, and speed. A vector can have speed. Yeah, I think it can have. I think, well, it's the length basically, right? So it can point somewhere, and you can see the length of it, and you can calculate the speed by the length of it. So basically that's a vector. If we see this as x, y, and z values, that's how Houdini access this. Or if these are colors, This can be R, G, and B values, red, green, and blue. Or if this vector is UVs, this is the U, the B, and the W attributes. So yeah, that's basically it. So yeah, it says the CD is a vector, and so the position is a vector as well, because CD has RGB and the position has XYZ, and the normal has 3 values that define the direction it's pointing at. And then you can access the subcomponents with a dot. That's good to know. So if we want to pass just the X value of the position, we just put a position and then dot and X, and that's how you pass the X value. And don't forget the semicolon there at the end. And then if you want to pass the Y value, you just put Y or Z. That's basically it there. So we can test this in Houdini really quickly and see what's happening. And if we replace that, you can see now, Control Enter, we're just passing the X position. And if we show the grid, if you want to know what's happening here, you can see here. What's the front? There we go. So here you can see the front of the pig, and here is the 0 value, and that's why here it's dark or totally black, or the values are 0, and then it's going from 0 to 1. That's why it has like a gradient there. We can move the gradient if we maybe subtract from this like -1. You can see now I moved the gradient over here. I actually flipped that. -1. Yeah, it's too far. 0.5. There we go. So I moved it over here. I need to add to it. Now I moved the 0 position here, basically. But yeah, we are just passing the position of the points. It's important that you know that we're working with the points position. We get the position of the points, and then we're passing that to the color. And the normal, yeah, it says that you can do the same thing with the normal. Just do N, Y, and we're passing the Y direction. You can see, looks like there's a light above the pig. So that way maybe you could fake a light, a top light. Cool. Let's not do that. You can see it looks like the pig has a light coming from above. There's no light, but since the normals are 0 where they start and then 1 where they end, they are kind of, yeah, something like that. All right, we can change this and see what's happening, which is pretty cool. You can see now it looks like the light is coming from this direction. All right, so let's see what else. VEX is doing a bit of the hidden work for you, taking the float value, converting it to a vector. Yeah, so basically what he's saying is that CD, it's composed of CD, I mean red, green, and blue, like this. So CD is actually CD has R. Oh no, don't do that. Has green and has blue. So it's a vector as well. So when you just pass one component, it's just gonna, if this is equal to 0.2, it's gonna add 0.2 to all of them. So it's basically doing that in the back for you. So it's saying like, oh, you just passed me one value, all right? I'm gonna put that same value to all values of color. If we put this and as a vector, and the vector is 0, 2, 1, 0.1, then it's gonna just distribute those values to this vector like this, like that. Okay, so that's what's happening there. Basic math. All right, VEX, it's based on C, like a lot of computer languages. Simply to do. For example, you switch to the grid. Let's try that. Let's see. It says that we should switch to the grid and put the position X, which we already saw this with the pig. So one side it's black because those values over here are negative. But basically here there are negative values over here. It's not actually black. And here over here there's values over 1 as well, depending on the position of the points. Oh yeah, here's what I was saying. You can add to the parameter here. Let's add 3. You can see we added 3, which means these values that were like -3 before, now there's 0 is here because we added to those values. And if we were at 1 here before, now it's like 4. And you can see these values if you want with the visualizer. Just pressing and holding X and clicking. You can see it turns like in an eye icon. Clicking on a node, and then we can see the value here. Let's see the. You can see it as a marker. Let's make it text. And let's put CD here, and you can see the values here of the actual values here. You can see here it's 888, which is red, green, and blue are 8 there. And why is it this weird color? I don't know why it's making it look different. Doesn't matter, but it's showing the right values. We can go to here. You can see their sides are negative values. Then we should get closer to 0. Here it's basically 0 is about here. So yeah, you can see your values as well. If you use visualizer, you can see any parameter there. So all right, so we can subtract as well from this. It's very simple stuff. Now we subtracted -6, which is going to be like all the way over here, which basically it's everything, it's black. Or multiply and divide. This is basically just getting silly, man. Come on, dude. But yeah, you can do this. You can use brackets. All right, yeah, you can use brackets to control the order operation. This is basically the same as any kind of math. If you go like, if you want to, let's say this is what I had. What I have in my file there. Let me close this. I think I need to make this font larger. Do you guys see that okay? 45. No, 450. No. Thank God for undo. 45. Yeah, I think that's as big as I'm gonna do it. What's happening here is that as in any math, symbols take precedence. Like multiplication is gonna be done first, and then it's gonna subtract here from this. So if you want to make this operation first, you can put it in parentheses and brackets. It's called here brackets. I called in parentheses. I don't know. And this operation is going to be done first, and then it's going to be multiplied. So you can see that that's going to be a different result. Crap, I scaled my window too much. Oh, no, I was not doing that. Come on, there. All right, so that's how that happens. You can control the order of operations here. With that, assigning to components. Earlier we were reading components and assigning to color. You can also assign to components. So we can do different things to. Oh yeah, so yeah, that's what I was telling you guys. You can, and also you can see here he's using X, Y, and Z for red, green, and blue. Doesn't matter. You can use RGB or X, Y, Z like he is doing here. And we could actually test that, see if I'm actually telling the truth. You can say, let's put PX to that. Yeah, you can see it does work. If you put use .R or .X, is exactly the same thing. Actually, maybe you can even use P.R. Doesn't make that much sense, but you could do that. Actually, I would recommend that you stick, since this is color, you can stick to using, instead of using XYZ, you should use like RGB, which is more understandable for color. But who am I to question the VEX, the god of VEX, which is Matt. All right, so this is doing it to the X value, and this is basically, we already saw that, so I'm not gonna explain everything here. It's gonna go faster as we move along, because you guys should be comprehending the topic. So you can see now, like the 0 point is over here, and then we had those colors added for those guys there. Oh, why am I getting the different result? This is not the oh, his grid, it's offset, it's rotated. Yeah, like he has the grid kind of like that. All right, that looks similar now. Perfect. All right, so let's move along. As far as we've been using P and N and CD, you know that each point gets its own ID. Yeah, so basically each point, it's basically saying that the ID for each point is the PT num, which is the point number here. So yeah, you can pass CD the point number here. I'm just typing whatever it's there, so you guys should be able to see it here. So yeah, this is not much here because the values are above 1. So basically start from 0, 1, and then everything goes white. Only the first point will be black, which should be one of these corners. We can turn it on here, this guy here, but it gets overblown by the other one. You could actually inspect the values here as well with the switching on the correction toolbar, showing that there. Oh no, wrong. Oh yeah, we could lower the brightness here. You can see now I'm lowering the values here in the viewport. This is just for viewport visibility, but I lower the values and you can see the values are there, but it's just because they are all above 1. Color can't show those values basically, or they are too big for color. Because point number is PT num 0 is blah, blah, wide it's 1. Yeah, so every point is super wide. Along PT num, it's another handy built-in attribute, which is the total number of points, which is num PT. That's number of points. Those attributes that he's talking about, these attributes that are built into Houdini by default. So yeah, to get a simple ramp from 0 to 1, you divide the current point by the total number of points. Yeah. Let's see. I think we should. We need to actually put. Let's hide that. let's say CD, not CD. It's very important as well if you're new to attributes in Houdini. It's very important to know that this is not the same as this. Capital CD, lowercase d is not the same as capital CD, or it's not the same as this either. So attributes are picky because they are based on Unix stuff. So capitalization of letters, it's important. So don't make the mistake of having lowercase letters if your attribute is named with a uppercase letter or something like that. So that's really important as well. So let's put a pt num divided by let's see if num pt, because I always need to subtract 1 from num pt, the total number of points, to actually have it go from 0 to 1. But let's see what's happening here. So I'm not, so that's weird. I don't have a gradient for some reason. All right, says it doesn't work. Okay, yeah. So it says that it has no fractional values. But we can see the values here. Oh yeah, there are all zeros here. So basically, if you are all thinking about what's happening, sometimes see your geometry spreadsheet and see that CD doesn't have any values there. So yeah, so it doesn't work. Programming languages deal with number, PTN are integer values, meaning they have no fractional. The ability to deal with values after a decimal point, when you decide, we convert this. All right, so basically it's saying that if we divide integer values, they will now return a float value or a value that has decimal points. And that's how precision kind of works in programming languages. Now you can cast a value to another kind of value or another type. Sorry, that's called casting. This is what it's saying here. And to do that, you use the float. In this case, the float expression here. So we do this. You can see it there, but basically we're casting one of the. You're just gonna need to cast one of the values. So basically, float takes a number and returns a float value, which this guy, instead of being 1, 2, 3, now it's gonna return this 1, 2, 3. I mean, no, that it's gonna be for each point. And then when you divide it, then it's gonna return decimal values there. And let's copy this and paste it here. Paste, enter, and now we have the gradient that we were expecting there, right? If we wanted, we could replace numpt with any number. Yeah, we could replace numpt with any number, because right now if we middle click on these guys, numpt is this value, which is 900 there, which is great. It's basically replacing that number. If we put 900 here, it's gonna be exactly the same. But if we put 100 like Matt saying there, it's gonna be brighter, because the value from 0 to 100, there's less range there. Cool. All right, let's move along. All right, we are, dude, maybe we're just gonna be able to cover day 1. Let's see how much of day 1 we have left. Poof, there's a bunch of left. Cool. All right, so let's go to channels. When using wrangles, you'll find that you get certain values you want to keep changing, like second part of the wrangle codable. Rather than consolidating in your code and hitting Control Enter, you can use the function ch, which is the function for channel. This creates a channel reference, creates sliders, creates parameter letter. Okay. All right. So yeah, we have the same code, and now what we're going to do is just replace this. We are, as the code said, put 100 there, but we can change that with a channel. Just creating the channel expression, scale. And we're basically saying create a channel with this name, or in Houdini basically is saying this is getting a channel basically and getting the value of the channel. But in the wrangle, since the value doesn't exist, it's gonna create an error first. You can there's an error there, and it was gonna say the channel doesn't exist. Well, there's no error. To create the channel here, you just click this guy there. And then you create the value here, and then you can put the value, whatever value it's gonna be passed here, which is pretty cool because you can control these guys, you can animate these guys, you can do a bunch of stuff with these values here. So that's pretty cool that you can have this interface to the expressions. All right, sign. We're getting to the fun part then. The sign function is basically the same sign function from math, just basically gonna create a wave, sine wave, and let's put the expression there because we're kind of slow at this. I was thinking that we're gonna cover like 2 or 3 days, but maybe not. All right, so that looks pretty cool. So this gives a basic wave function that oscillates between 0 and 1. Because VEX is for nerds, science uses radians. It says meaning it does a 0 to 1, meaning it does a 0 to 1 to 0 to -1. All right, so yeah, it's going from 0 to 1 and 0 to -1 to 0 every pi times 2 units. So because you're doing PT num, we get a wavelength roughly each time the PT num is a multiply of pi times 2 or 6 and some and a bit. So that's what's happening here. We get a wavelength of that size, 6.3 something. If we want to change how often it repeats, we divide the value into, yeah. So basically, if you want to change the frequency, is it the frequency? Yeah, you divide this guy, and then we have less repeats, but it doesn't look cool. So that now it repeats more. Let's put the. So there you go. And oh yeah, now we are dividing by an integer again. So we can cast this one to we can just put 20.0 here, and that works as well. Instead of just casting this guy to float, we can just make this 0.0, and that will be maybe the same thing like that. That should be the same as what he's doing here. Yeah, I'm just gonna be going through VEX this time, but if you have a question about Bob's, go ahead and ask it, and we can see if we can try to answer your question. So basically, what I did is just make the value float instead of floating the value, casting it to float, which is basically the same thing. You can see it's totally the same thing. But depends on your use, because now here he wants to use the scale attribute we created before again, and that it's on integer. So scale back. Now we can change this guy and we can control the length of the wave there, which is pretty cool. Look at that, looks pretty awesome. All right, so it's saying just for clarity, he's trying to break the code into different components. So basically, let's do it over here because it doesn't look that well over here. You can see here he's doing let's call him float foo. It's creating a variable here. So float foo creates a variable, and in the variable it's gonna get this part. We're just breaking it into two sections, and since this is a float, I think the division doesn't have to be. No, we still have to cast this to a float. So let's grab this complete and semicolon at the end. And the next part is just basically now declaring the color, passing that attribute, the scene function and foo there, like that. So instead of having everything in one line, we just broke it, and now we have a variable, and we're passing that into the sign function. It's basically the same thing, but it's a little bit more understandable. You can see the result is exactly the same, but you have it in two chunks. Variables. So yeah, things prefixed with the at symbol are attributes. So that's data that the geometry has here. You can see these are attributes, CD, N, and P. Other geometry might have more attributes. This only have P and UV. This guy has N, P, and UV. And this is point and this is vertex attributes, so they are different. So let's go. You can both read attributes and write to them. Yeah, you can read attributes and write to them like we are writing to the CD attribute there. Putting an attribute equals to something, it's basically writing to that attribute. Okay. Let me turn the light on really quickly. Alrighty. Cause see what's getting it's getting dark here, and my skylight was getting dark. Was getting less light. So yeah, you can first work out the times plus that run through functions such as with the slider. Yeah, so basically saying you can do stuff before you write to the attribute. So basically this is what we just did here. We computed this stuff and then we wrote to the attribute later. Yeah, so this attribute, it's not gonna be passed to the geometry. This is just an attribute that's gonna be. I mean, it's not an attribute; it's a variable. So the lifespan of this attribute is gonna be here. So you can only use this here. After this guy, if we put a null here at the end and we try to look for this, there's no foo attribute. Actually, we don't even see it here. It's just a variable inside this code. So this foo variable is never gonna live after this. So if you want to get it, use it later in another node, you need to make it an attribute. Variables exist within the wrangle only. They never get transferred into the geometry like attributes. Remember that. Variables stamp throw away data. That's only exists within the wrangle code. What's wrong with my dog? I don't know. Alright, so that's it for that. These waves are based on PT num. if we want to drive them for each point X position, substitute ptnum for point X. So let's just substitute this here. Px, and then we have that, which like that. Now they're going in the X direction here. I mentioned earlier that the components of P are floats. So yeah, you don't have to cast that to a float here. So doing this it's just useless. So basically we're casting this to a float, but the position it's a float already, so we don't have to do that. No, don't change that to primitives, dude. And then we're gonna have the same result there. All right, so we got to the all right, we got to the final part, I guess. Yeah. So exercises, sine waves on the z-axis. Well, we just changed this to the z-axis. There we go. Sine waves on the y-axis. Sure, we can just change this to the y-axis, but it's not gonna be shown on this geometry. So let's change to the sphere or the pig. And you can see we have that, but the scaling needs to big for that pig. So we have now on the y-axis cosine waves. Basically, if we change this to cosine, which is COS, you're gonna have basically the same waves. The magic here, it says that the cosine is just the sine shifted by a quarter. But if you mix the two is when the magic happened with these two waves. Waves based on normal components. We could just change this instead of the position. We could just choose the normal. Whoa, that looks cool. We can change the normal Y, and now that looks much better. Let's subdivide the pig a little bit more to have more resolution on it and see how it looks. So there we go. That looks better. So those are waves on the Y. What am I doing? There we go. Is it working? Yeah. On the X normal. Now that's looking better. Normals are floats, right? Yeah. All right. Tight sine waves on red. Medium on blue and white on green. Woo! Each driven by a different thing, position, normal, and all right, we could do that. Let's do that. Let's get the code we have, and let's create different attributes. So we're gonna derive them differently. So let's call this scale X. First, I'm gonna say let's do X pose X, position X. That's gonna be, let's call it red, because we're gonna do red, green, and blue. Position, the red is gonna be sine wave based on position. Let's go for position X, and we're gonna call it scale X, and then we're gonna duplicate this guy 3 times, and we're gonna say the second one's gonna be red, and it's gonna be green, and this is gonna be blue. So the second says driven by the normals. Let's put it the normal attribute there, and it's gonna be scale Y. It's gonna be scale Z. And the third one, the point number. So ptnum. All right. So now we need to assign it to different attributes. This is gonna be the red. It's gonna assign it the red. Copy, paste, and paste. Red, green, and blue. It's gonna be assigned it green. And this is gonna be blue. And if we copy that, go into Houdini. No. Paste. What did it do? Paste. So there, but we don't have these attributes. Create those attributes. So add type sine waves on red. Type will be small number, and medium on cosine, medium, and white on the other. That's PT num. Oh, this one we do have to. We forgot to cast this to a float. Float like that. So let's copy that again because we are doing integer values there. And this should look better. And it's looking the same. Does someone else see an issue here with me? Something I'm missing? Or is it just the nature of how this is gonna look? Alright, so I think that's the exercise is done. Let's save this. Save us day 1. Day 1. Day 1. 01. Alright. Background bonus material. Note that one linear is pretty elegant considering that it's doing. Alright, we should just read this by itself. If there's any, are there any questions? Yeah, but in the blue we didn't have integer, and we had an integer and an integer. But this is a float. But yeah, I was using something else, right? Not sure. All right. Well, if you have an integer here, you do need to cast this to a float. So it's safer to cast it because this guy could be a float if you drag it like this, but if you type like 200, could be just integer, and this will be an integer by an integer, and you wouldn't have like float values there. All right, well, that's an hour. Cool. All right, let's just preview day 2. Let me just finish reading here. You have to think up your ways of speeding up your performance. Software receptive slow. VEX does all the work for you. That's pretty cool. Downside of coding, especially in something as bare bones as the VEX Wrangler, is that it's pretty unforgiving. When everything goes wrong, messages are arcane, blah, 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 right? Okay, cool. So we did finish day 1, and that took a while actually. Let's see what's in day 2. Day 2, it's has a lot of functions. Length, cool, length, distance, and more on code styles and exercises. Okay. You can modify the channels when you create the channels, or you can create channels like these channels are float by default, but you can create You can create CHI would be an integer channel. You can create CHF for a float channel if you want to do that. Even if this is just gonna be float. You can also create, what else? Let's see what else is here. No, just that it. Integer, float, there's no doubles in VEX. Yeah, you can use CHI for integer channels if you want to create it like that. So, alrighty, I guess we are done for today. Oh yeah, there's the channel ramp. It creates the ramp, but it's not just a slider. It creates a ramp. Creates a ramp attribute like the ones that are on those kind of tools. I don't know. Day 2. Yeah, we're gonna have to leave it for next week because I don't know. It's gonna take forever if we do it like this. Should we just go ahead and go for it? VEX has a lot of functions, lots. There are an alarming list of them. Bookmark it. You use it all the time. You get familiar with it. So this is the documentation for the functions. Cool. There's a bunch of functions here. You can read about them. Let's see what else here. I would start a simple word, measuring the length of a vector. So yeah, as I was talking before, or saying, mentioning at the beginning, vectors, you can actually, let me save this as day 2 before I make a mess. And I am going to day 1 leave that there. So let's keep going. Let's see how far are we gonna go here. So float d, it's equal to length of the position attribute. So it does nothing because we're doing nothing here with that value. Tells you the distance a point is for an origin. Put that into color. We can put that into color. Let's go faster to cover maybe 2 days. So there we go. Let's switch this to grid. So there it's telling the distance, getting the length of each one of those points. Since this grid is on the center of the world, it starts to make this kind of a circle because at the center it's a 0. Vector channel. Yeah, you can create a CHB. No, you can change the attributes here. How do you create a vector channel? Oh, you create a CH3 channel. That's how you create a vector channel, like CH3. Like, let me just create it really quickly in another Rango. Attribute Rango. You can create it like this, CH3, scale, and there we go. Oh, that's a 3-3. That's not what we want, right? Channel float index name input. You can create a channel for a string as well. I don't think there's a way to create it like this. Is it? The only way, I think the only way you could do it, I'm not sure, but you could maybe just, after you create the channel, let's create another channel, let's call it position. After you create the channel, you can just go to the edit parameters interface and change this guy to size 3 and apply, and there we go. Position is now 3, a vector. I'm not sure if there's a way to create this directly here. I'm not sure. All right, so length, it's getting the length of from the origin to the point. So now let's put that into a sign. We're just wrapping what we had here as before. Now we have that guy. We do the same thing we did before, like let me delete the attributes here that I have. Delete these guys, apply, accept. Now we are going to multiply D times the channel. We create a flow channel scale like that and create the channel, and now we're gonna have this waveform we had before, but now in a circle. We're calculating the distance from here to the points, and then we're putting that into the wave. All right, so you probably need to set the range to see the sine waves better. Okay, we're done with that part. Okay, it's saying that if we go here and see the values of the color, you can see the dark values are going below 0, which is negative values, because the wave, this is 0, and the wave goes from here to 1 and then comes back and goes below 0 and then comes back, and that's what's happening. And these values are passing to the color, even though we're just seeing black. They are not actually black. They're values below 0. So let's see what he's saying here. We can add an offset to get them out of the negative. That's yeah, that's, you can add 1 since the wave goes from 0 to 1 and 0 to -1. If we add 1, now the center of the wave is going to be 1, and then it's going to go from 1 to 2, from 1 to 0. So basically we're just moving the wave above 0, and that's what's happening here. Now we have no complete negative values here. If we go to the CD, we have no negative values there. Cool. And the colors are still not right, as now we're getting values going between 0 and 2. Yeah, because as I said, we just move it up. The length, yeah, the length measures from the origin to the point. I'm going kind of fast here, but if you guys want to get these details and read everything in detail, you should need to go to the page here. You can see this. It measures the length of a vector. So basically, this is measuring, and for each point, it's getting their position, and it's measuring the length of it. Tells here we go. Tells you the distant a point it's out. It's the distant a point is from the origin. So basically, the origin of the world. If the point is over here, it's telling you the distance from here to that point. So getting every point like that. So that's basically why, if we have the grid on the center, it's looking like it's spreading away from the center. If we actually move the grid from the center, it's gonna start shifting. You can see that wave seems to be standing there because it's measuring from the origin of the world. All right, let's keep going. I was over here. We can divide it by 2 to get the range from 0 to 1 instead of having. So basically, now we have it from 0 to 2. We just divide that by divided in 2, and now we're gonna have 0 to 1 because we're just dividing that. So there we go. We have 0 to 1 values. Some coders frown upon using divide. Yeah, some people said don't use divide. You should rather use multiply. I'm one of those guys that use divide a lot. So, but yeah, multiplying by 0.2 is basically the same thing. Breaking these across three lines is a matter of style. Specifically valid if those lines are together. I'm just saying that you could get this guy, put it over here, multiplying this line instead of being there, and you will be the same. But this is basically just breaking it for clarity, I guess. And this, yeah, if you put everything in one line, it will be kind of harder to read there. So now let's get distance. Related to length is distance. Well, length measures the distance from the point to 0, 0, 0. Distance, let's measure the distance. I guess. Let's measure distance. Let's measure the distance from the point to another value you specify. Vectors. All right. So yeah, distance is gonna measure from whatever point you declare to measure from, right? So let's go to here. Oh man, I screwed up this, right? Because this was chapter day 1 homework. I will see if I can get it back. If I can't, I'm just gonna, I don't know what I did. I'm gonna close it. Don't save it. Let's see if it's there. Okay, that's what I had. Cool. Let's create day 2. Day 2 VFL. I should just keep these things here. So now we're gonna go for the distance, and basically I'm gonna put the same thing. Put distance here, and distance takes 2 arguments. Distance. We can't see it here, but distance takes position 1 and position 2 here. So position 1 is gonna be the P, and position 2 is gonna be this weird notation for 1, 0, and 3. So basically, this is how you declare a vector in VEX, and we're measuring now the distance from the point to this position in the world. That's what's happening here. So let's, instead of just measuring from 0, 0, 0, and let's paste that, and so there we go. You can see now the center shifted here. If we move the center to maybe 2, it's shifted more towards X. So basically we're just shifting the origin of where we're measuring from. There's another channel called, oh, there's a channel B. That didn't show for me. So there is a channel B. It's channel B. Yeah, there is there. I don't know why it didn't show before. So we can actually create a vector channel. So let's create a vector, another type of variable, call it center, and you can create a channel B, which is gonna create a channel vector. Duh. Again, we're learning together, guys. Learning together here. So instead of passing now this hard-coded value, let's put center there. And now we can pass that to Houdini. And it's gonna fail. Well, it's not gonna fail because this is 0, but if we create that now, here is channel value, channel vector. Sorry for that. I did not know about this guy. So there we go. I need to distinguish to multiply vectors p by something. All right, so we can multiply the position, saying that we can multiply this position. This guy we can multiply it by another vector, and we can say 0.1. Basically, we're scaling x here. 1 is gonna be leaving the vector as it is, and so basically we're scaling just in y by half of it. So that's what's happening here. Let's go over here. So there we go. Let me put the center somewhere we can see it better. So there we have squish circles now because we're scaling the position. Again, my tidy gene wants to kick in and make the things easier to read. So it's just cleaning up the code. It's basically creating a vector for the position, which is gonna have this part. Yep. This part's gonna be the position. The position has this, it doesn't. Okay, it's creating another channel for the for this channel vector. Fancy scale, it's calling it. And the center, no, it's not putting the center here. Then that's the position. Then we have the center. Move this up. Come on, you don't know how to put this. Alt, yeah, right. So now we have the position, the center, the distance. We don't have this. This is lower. Have it twice. The distance is the position. We use now this variable we created here. We use the fancy scale here, I guess. Position and center. Just the position and center here. And then we have this scale. We have this blah 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 blah. All right. So he removed the scaling. No, it's scaling here. We're up there. Sorry. So let's put that there and kick here. We have this. This should be, since this has been multiplied, should be once by default, but if we put it to 0.1, 0.5, we get that stretchiness. And or in this axis, that's too stretchy. That's not what I want. There we go. So now let's check it. Movable squishy rings. Yeah, if we move this guy, if we change the scale, we can change the scale of this. We can move the center, or we can move the scale. So that's what we have. Okay, so it's talking about deleting some channels there because a scale it's not a vector. What is it doing here? The little sphere. Oh, so it's basically making a scale a vector as well. So let's just make this guy a vector and deleting the sphere parameters here. So it goes away and you create them again, and now the scale it's a vector again. So now we can put maybe 3, 1, and 1, and the scale should be 1, and the center can be anywhere we want. There you go. This doesn't have any effect there. All right, what else? When we divide it by 2, can be replaced by a fit function, yeah. And the fit function can have the min and max value. So basically, let's copy this guy. So here we have this right now to put the wave in the position we want it, but we can say fit, and the fit function takes a minimum, a value, which is going to be this is going to be the value we want to fit. Then let me delete the rest of it. So the first thing is the value that we're going to fit. Then we just say from -1 to 1, which are the original values of the sine wave, goes from -1 to 1. The minimum value, the maximum value, we're gonna fit those. Basically, this minimum value is gonna become 0, and this maximum value is gonna become 1. It's gonna stay the same, and that's how you replace that thingy. And we should get the same exact result right now without having that multiplication there. And finally, introduce time. We introduce time, which is attribute time, which is a variable for time in Houdini, basically. And let's put it here, times at time, or attribute time. And then if there's nothing happening here, but if you play, now things happen. So that's pretty cool, right? Pretty cool. Now they are moving. It's starting to get really interesting. So now it's talking about code style, and I'm not gonna go through that. You could guys read it. I'm gonna read it myself. And code style, it's cool. Then we have exercises. So let's do the exercises. Change the direction of waves move from towards the center to away from the center. So the direction, the waves are moving towards the center. Let's move them away from the center. Maybe if we put in the distance, put the center to the position like that. Should that be it? No. Away from the center, position negative. That's just making it go the other way. Let's put the center to, that's doing the same, right? It's not doing what the exercise says. All right, no, I don't know what. Change the direction the waves move from towards the center to away from the center. I don't know how to do it. You guys know how to do that? Maybe scale by times -1. I think that's it. I just changed the direction, multiply it by 1. They're moving away from the center now. Cool. I did exercise 1. Change the speed of the waves. Yeah, just multiply time. Let's put into parentheses time times 10. Multiply that, and the time is gonna be faster. We can put this into an attribute if we want. Channel time. Create that. We have time here. Now we can control how fast they go with this guy. Five. Make the waves be blue on black or yellow on green. Okay, so let's CDR. Let's just change this to CDR. No, blue. Red. They are blue on black. No, that's not what I want. What if we no. Okay, those are not blue. Not blue on black or yellow on green. Let's pass the same thing to, let's say, copy this line to the green, blue, red, green, and below. They are black, but the white is... I don't know how to do this. Nope. So I have the black areas as we can do CD equal to the I don't know. I'm gonna do this after, so we don't have you guys here all day. Rather than affect color, make them affect the position of Y. Oh yeah, this is a good one actually. Let's go, and instead of doing that, let's put the position Y. Just paste the line that we had. Put attribute position Y. Now that's pretty cool. There we go. Now we are affecting Y, but we can leave the color. So there we go. 2. That's pretty cool. That's pretty cool. I need to do this, make the waves be blue on black or yellow on green. I need to do that. I'm not thinking straight about this, but yeah, there we go. So, okay, that's day 1 and 2. Juan Carlos, do the question, because we're gonna finish for today. That's day 2. Pretty cool. So we did day 1 and 2. Maybe as we'll move along, maybe we can do 3 days, because if not, this series is gonna be very long. All right, cool. But if you're doing this at home, you can do more than once. We just did 2 in 1.5 hours, and I'm explaining stuff and things. So yeah, go ahead. If there's a question, go ahead. Again, if you are, oh, I wanted to say something. Let me switch here. So if there's any questions, go ahead. We have like, let's say 10 minutes for questions. And so one thing I want to say, I mean, two things actually. Let me go back to my, if you are a patron of mine, or if you want to be a patron of mine, go to Patreon/mixtraining. You can become a patron of mine there. If you are, tomorrow there will be a live stream, for Patreon exclusive guys. Those things don't get recorded, so you need to be there to enjoy it. It's gonna be tomorrow, 6:30 p.m. That's one thing, and the other thing is, if you are enjoying the work that Matt is doing, go and become a patron of his. I'm already there, and go there, click that link at the bottom, and get the guy some money. He deserves that money. Go ahead and do it. I supported him with a few bucks, not just one. You can give more than one, by the way. All right. When you go here, you can give more than one. Don't stay with one, please. At least two. But it's up to you. All right. So that, go support Matt. Matt, it's amazing. It deserves that for real. So let's see what the question. What's the question? So he's asking why I don't do videos in Spanish. Because there's too little market for Spanish. So yeah, I tried doing videos in Spanish, and people don't really take you seriously, and they don't appreciate it, and it's really like too little people that want them in Spanish. And if you really wanna, and my main reason is this, if you really want to succeed or have success in the visual effects industry, you need to learn English. If you always want to live in Mexico, you don't need to learn English, but still all manuals are going to be written in English. All applications are written in English. So if you want to be ahead of the curve, you have to speak English. It's basically how the industry works. So that's why. Okay, so what else? Are there any more questions? Yeah, Matt, it's an amazing person, and he does a lot for the Houdini community. So if you are using his stuff, please go and give him some bucks. He will really appreciate it. All right, so I want to thank Matt again and Grant for the guide. Matt and Grant helped a lot on help Matt going through the guide and seeing what worked, what didn't, what was maybe confusing and stuff. So thank you guys for that. We'll be back next week for maybe part 3, 4, and 5, hopefully. Any plans on making more quick Houdini tutorials? There is new tutorials on the side. So if you go to YouTube Mix, the YouTube channel, I just posted one for Redshift here. This one here. Just posted that like Monday. What is it today? Wednesday? I don't know. It says a week ago. Yeah, it was posted like on Wednesday because I had issues with the internet thingy. I'm glad that today the internet actually is fixed because we haven't dropped the connection. We're still streaming, so yeah. So is Redshift worth it? Dude, Redshift is great. You should buy it. Redshift is amazing. Redshift is incredible. Redshift is... I can't say enough about Redshift. Oh, you didn't see that I was showing you. That's my big face. Just this one. I was saying, this is what the one I was pointing at. This is the tutorial I did last week. So if you want to go ahead and see that, there's a bunch of them already there. So, all right, I think that's gonna be it for today, guys. We had a really cool session, but Arnon is working on a GPU render. Well, they keep working. Redshift is already out there, man. All right. I'll see you guys next week, all right? Because I'm tired. It's been 1 hour and 40 minutes already. Whoa, man. I need some. Oh, I have my drink here. I don't know why I haven't drank my tea. Redshift is really fast for a lot of things. It does have some limitations, but it is faster than Mantra for a lot of things, but it's different. So you can just compare it directly because they are not the same thing. Mantra and Redshift are different. Mantra has really amazing things and gives you really cool results, but some things takes a bunch of time. And Redshift does some things really fast, but some things is lacking, like flexibility and for volumes and stuff like that. But it's getting better. But Redshift, it's really cool. All right, so cool, Orlando. Cloudy. Is cloudy in Mexico City today? I bet everyone is using jackets today. In Mexico, they just see a cloud and everything it's cold. No, I'm never gonna do versus thingies, Arnold versus Redshift things or stuff like that. I'm never gonna compare stuff like that, like do this against this. I'm never gonna do that. This is not the channel for that stuff. I use Redshift, I use RenderMan, I use Mantra, and I use them all for their strengths. So I'm never gonna do versus thingies and saying this is better than that, this is better than. No, I'm never gonna do that. So this is not the channel for that. All right, so that's it, guys. I need to stop. All right, I'll see you guys next week, and next week we should do more VEX, more faster because we just did 2 days, so we have 18 days to go. All right, I'll see you guys next week. Thank you for being here. Thank you for your questions, and thank you for your interest in us. Again, if you want to support us, you can go to our Patreon, go to Matt's Patreon, and I'll see you guys later. All right, let's keep learning together. All right, cheers. And need to find that button. There it is.